Did you know that people who make graphs can actually mislead the people who read the graphs using some of these classic ways of misleading people? The first example is called omitting the baseline. So the baseline is where your scale is going to start on our vertical axes. Let's have a look at two examples. This is the misleading graph. This is the accurate graph. This graph starts at 50 with its scale and it goes up by a constant scale each time, but this one starts at 0. Now, the difference is because this graph started at 50, you end up having a bigger gap between your bars. If you started at 0, you can tell that there's actually not a big difference between these three sets of data, 62% and 54%. But over here, because they've zoomed up essentially on their scale, you can see a bigger gap happens here. You can mislead people by zooming up in your scale. Number 2, manipulating the y-axis. Now, the y-axis is another name for the vertical axis. So, depending on how much of your axes you include, it can actually change the accuracy of your graph. Let's have a look at the misleading graph versus the accurate. This scale, or the y-axis, goes from 0 to 40. Now, have a look at the data that we have here. Do we need our scale to actually go to 40? No, we probably only need it to go to around 15. That's as high as our data goes. So that's why this accurate graph has gone to 15 in its scale. The reason that this misleading graph has gone to 40 is that the more scale you include, the less of a difference you can show in your graph. Look at the accurate one and how much higher the data is climbing. If you want to flatten your curve and make it look like it's not climbing very high, give the person unnecessary scale, as you can see over here. Number 3, we have cherry picking data. Another way of saying this is just not including enough data or information in your graph to start with. Let's have a look at these two examples. This graph is showing some sort of change over time from May 20 all the way to August 20, and it looks like it's going up quite significantly. This is our accurate graph. Now, they both have the same scale from 0 to 30, but this graph has given us information over many years. We've got 2019 all the way to 2023, and would you look at that, it does climb just like this one does in the year 2020, but then it goes significantly downwards after that because we've included more data. We haven't cherry picked the data. We've been honest with our information and we've included more information over many years. The more data you include, the more accurate your graph is. 4, we've got using the wrong graph. Now, depending on the type of information you've got will determine what graph you use. This is an example of an inaccurate or misleading pie graph. All pie graphs show information part of a whole. Now, does 38% plus 50% plus 60% add to 100%? No, it doesn't. It's clearly misleading. Team C, A, and B should be shown side by side in a bar graph. With a bar graph, it doesn't need to add to 100%. So this is just all about using the right graph for the right information. And finally, we have going against conventions. Let's have a look at two examples. Now, they're showing a map of America and the different states, and they're both showing population density, which is how many people are in one area, how squished in they are, really, individuals per kilometer square. So normally, darker shades on a map are associated with larger density. And we know this. This is something that we call a convention. Darker shades equals more percentage of something. But this map has thrown it round the other way. It has said that the darker the shade, the more individuals there are per kilometer. Over here is what it should look like, with less individuals in an area being shown by a lighter color all the way up to a darker shade. So this map is truer to the conventions that we have about scales and colors. So readers will intuitively or automatically understand that lighter colors equals less people. So this one is a cheeky one because it just changes our understanding of conventions.